Welcome to Climate News Weekly, here with Darren Howe and Julio Friedman. Hi, guys.
Hey, it's been a hiatus, but it's good to be back.
Always a pleasure.
Awesome. So, we've got a big lineup today, a lot of sort of different stories. We're going to start with a story in the Times. Julio, why don't you kick us off here? Richard Benedict has passed. Who was Richard? And I believe you knew him personally.
Yeah, so Richard Benedict is one of these amazing, important figures in the climate world that few people know. He was a key negotiator for the Montreal Protocol.
Mm-hmm.
The Montreal Protocol, again, stopped the ozone hole from growing. It had to do with the compact around specifically chlorofluorocarbons and their role in ozone destruction in the stratosphere. And the chemistry was sorted and the science was sound, but they needed an agreement. And the Montreal Protocol was an amazing accomplishment of statescraft to get the nations of the world to agree to phase out CFCs and embrace HCFCs instead. And Richard played a huge role in it. He was a kind, generous, gentle person. He was insightful. He was dynamic. We've lost a giant this week.
It's so sad. And you think about at the time, you know, the EPA estimated that this agreement would prevent 27 million deaths from skin cancers. Not many people can say that their work contributed to literally millions of people saved from death by cancer. I mean, it's quite astounding.
Not just that, people often don't remember how grim the picture was around the ozone hole. It looked like it was going to kill amphibians worldwide. That was an example of one where they were like, oh my God, they really can't handle the UV radiation. So he didn't only save people, he probably saved species and possibly big chunks of ecosystems as well. And we have witnessed over our lifetime the ozone hole repair. It has begun to improve and shrink. That was predicted that if we could pass this agreement, it would get better, and it has. And it took about 20 years to see it, but it has. This is important for climate change, too. These kind of agreements, like the Kigali Amendment, which is a follower to the Montreal Protocol, these things actually take a long time to manifest, but you can see it. You can see the physical change in the world. And so it gives one optimism about what we are able to accomplish.
And in a world where there's so much negative news, it's so great to sort of dwell on stories like this and people like this who really are our leaders and show us what's possible. So thanks, Julio, for flagging that one. Let's move to another story, which many people read in the New York Times that came out earlier this week on a technology known as marine cloud brightening. So we've covered this in the past in other content at Climate Now. It's one of the different solar geoengineering strategies or methods that people have been thinking about and writing about since the 90s, but this is a sort of pretty important experiment to test a couple of aspects of the technology. Julio, I know you know the team that put this experiment together, so tell us what are they testing and what is their work all about?
So, for those of you following along at home, solar radiation management is basically about changing the amount of light that actually lands on Earth. It is about reflecting it out back to space before it comes in. And we're talking about a very small fraction of it, about like a percent or even less. And there's lots of different ways to do it. Many of your listeners may be familiar with stratospheric aerosols as one way to do this. This is marine cloud brightening. And basically, what you're doing is you're creating low level clouds like in the first 2 kilometers above the ocean that are bright enough to reflect some stuff into space. They are basically using seawater to do it, which is what clouds normally use. And they're using tiny, tiny droplets of water. That's what they're making. So the broad environmental impacts of this are likely to be pretty small. You're basically taking seawater out of the ocean when it falls back into the ocean. In order to do this, though, it's pretty technically sophisticated. This pilot test is using ultrasonic nozzles to generate these tiny particles. They have to be really small or else they just fall right back in the ocean. You have to make them small enough to stay aloft like a cloud. This has been pulled together in part by a group called Silver Linings, and they have been a group focused on marine cloud brightening for a while. And this is a very scientifically rich thing. It's being done with maritime and environmental experts from around the world. It's being done in partnership with ports and with massive technology developers. I'm really pleased with this. University of Washington, in particular, Dr. Sarah Doherty was sort of the key actuator here. She's the one who sort of said, I think we can figure out how to do this. Her participation and the whole science team participation is really something else.
Yeah, it's very exciting.
You can't talk about solar radiation management without talking about the moral hazard around it.
Hmm.
I want to acknowledge that there are some groups who are concerned about the fact that this will somehow lead to greater or unfettered use of fossil fuels and lead to greater emissions, that this will somehow diminish the drive for higher ambition. I certainly don't agree with those people. But in climate mitigation technology, solar radiation management, this is a real concern. And so the governance issues are important around this, but we can't even have the governance discussion until we know if a technology works. I'm pleased to see these kinds of pilots because we can start with a factual basis on which to think about what's the right or wrong ways to go about this effort.
Right. Last week we talked about some of the uses for artificial intelligence, machine learning in climate, and modeling solar radiation management or sunlight reflection methods, as it's increasingly being called, like is one application of AI. So there's some interesting work being done on what are called emulator models, which essentially emulate or mimic the results of very computationally intensive climate modeling with much more streamlined, lower cost, more efficient neural networks. So you can use these neural nets to kind of emulate or simulate the effect of running a very complex computationally intensive climate model to figure out what might happen if you were to say inject aerosols in the stratosphere to replicate what might happen in terms of sunlight reflection. And so what's very interesting will be to see how we start to assess what the impacts of some of these you know sunlight reflection methods could be should we decide that there's no way but to deploy some of them. So Darren, maybe you could give us some insight into some new rules that have been advanced in California related to energy production and at home energy production, solar and batteries. What's going on today in California when it comes to renewable generation?
Well, as folks who are in the space know, one of the biggest bottlenecks has been interconnection of new renewable and battery storage projects. Even if you can get the equipment on time, which, the supply chain issues have been largely worked out, although batteries are still delayed. Usually, the longest lead time item is waiting for the utility to approve an interconnection because they need to make sure that any new production is not going to overstrain the grid and cause issues for the entire system. Very legitimate concern. The issue has been that the way that utilities have done this historically has been extremely conservative. Unsurprisingly, they have this massive machine they're trying to keep operating 24/7. They need to make sure they don't break it. So they often assume that a system is going to input the maximum nameplate power at all times, and then they're going to make sure that the grid can handle that. The new rule that has been proposed in California is called the limited generation profiles rule. And essentially, it allows utilities to say, hey, at different times of the day, we have different situations on the grid. Maybe at noon, we can have batteries consuming more power. And then maybe at night, we can't have them consume power. They should actually be delivering power. And essentially, what it's doing is allowing projects to abide by those time bound constraints and then get through a streamlined interconnection process as long as they abide by those constraints. This is going to be pretty interesting because, A, it does have the potential to streamline the approval of new renewable and battery storage projects. One thing just to keep in mind is that the very definition of this means that we're using things more efficiently, which means we do have less buffer in the grid. I've read some reports around how in the US, our distribution transformers are usually sized with a buffer, but certainly not as conservatively as in Europe. So now that we have transformer delays in the supply chain, we actually are less able to just say, "Oh, well, we'll use it a little bit more than they were initially rated to," because we've already kind of used them up to their capacity. So I think in general, this is a great rule. It's very useful. Just something to keep in mind is how do we apply some degree of resilience to this? Julio, I'm curious to hear your thoughts on it.
Right. So this is proof that things can get better. Again, we often imagine the world as it is as static, but the things can get better. This is an example. Doing this kind of dynamic response for loading as a way to manage buffer pools, risk of interconnect, all these other sorts of things, it will hopefully lead to a more stable grid, and I expect it will, and it will hopefully lead to more behind the meter projects, and I hope it will, and it will hopefully lead to better integration of these distributed resources onto the grid. It's actually a very deeply technical rule. And there's a lot of real tough nitty gritty stuff in the heart of it about what is allowable and what is not. I expect that over the next year, we will start unpacking that and find points of friction or things that don't quite work. That's okay too. Like, that's why we do these things. That at the end of the day, they will get better too. This is not a panacea by any means. It is just one of the many things that we need to do. But in that context, boy, glad it's done.
Absolutely. One other thing I'm hopeful that this will do is it'll nudge more utilities, or at least utility regulators, to ask utilities to provide capacity hosting maps. Different states have different policies around this, but the ones that do have utilities show, hey, here's how much capacity is at this little region, it's incredibly helpful for developers.
I'm trying to understand the rule, and I think for some reason I'm not getting it. So just in case others listening don't get it, I wonder, Darren, how does the limited generation profile regulation, which allows a power developer to decide when to inject power into the grid, when to service the needs of the grid, how does that help from an interconnection standpoint? Like I'm not getting the connection between this limited generation and then how it helps from a getting your interconnect faster. Or maybe I'm misunderstanding that.
I'm happy to chime in, Julio. It looks like you have some thoughts.
Yeah, so the way that it's done right now is that as part of the interconnect review process, it assumes that all generation is full nameplate at all times. And that can destabilize the grid, which limits the review process. You have to make a power flow model which is operated in order to get the interconnect. You have to do all these things. So here what they're saying is, instead of taking this assumption which is really conservative and probably not correct, maybe we can use more dynamic realistic data, and because that will be, if you do that, then every project doesn't risk destabilizing the grid. You can get more projects in.
Yeah. So, for example, in California, you definitely don't want batteries drawing power from the grid at, say, 4 to 9 p.m. in the evening. And as a matter of fact, if folks are operating their batteries correctly, most of the time the batteries will be providing power to the grid. But the way the rules are today, they need to assume that if those batteries were consuming power from the grid, that the grid can handle it. And that holds things up because it requires upgrades.
I see. Okay, so we're essentially what's happening today is power developers are being told that, they're responsible for these massive upgrade costs. That tends to stop projects. With this limited generation profile that's more realistic, that will happen less of the time and more projects will come online. Okay, thank you guys. So I said we were jumping around a bit today, and we are in fact going to do that now. There's a story about an interesting company, a startup, Graphite, they're called, with a Y, whose model is to store biomass underground. So we're talking about agricultural residues, woody biomass waste that they are putting underground in order to more permanently sequester or prevent that carbon from going back into the atmosphere in the form of CO2 or methane and causing warming. So, Julio, our carbon wrangler, tell us about graphite. What are they doing, and what do you think of it?
So this falls into the category of things called bikers, biomass carbon removal and storage. To refresh your audience's memory, bikers does not have the word energy in it. You don't turn the biomass into energy and then manage the carbon after you do that. Here they're just like, well, let's just take the biomass out. Essentially, you're trying to replicate things like what bogs do. Bogs take biomass, they put it in an environment where it doesn't oxidize, and it keeps the biomass there for a very, very long time, hundreds or thousands of years. This is a artificial way to do that, and basically people are taking agricultural waste or forestry waste or municipal solid waste. They're basically making bricks out of it, wrapping them in cellophane and stacking them up in a vault that will remain without oxygen, and therefore the biomass will just stay there. It's a form of what's sometimes called wood harvesting and storage, or biomass harvesting and storage. It's kind of a Russian tractor pathway to do this stuff. It's pretty straightforward and simple. There's not a lot of complexity involved. But it is, in fact, removing carbon dioxide from the atmosphere. Those plants get taken out of the system. The plants themselves take CO2 out of the air. What replaces them takes CO2 out of the air. So it's proper carbon removal. And it is a new pathway. And so it sits outside of a lot of the existing sort of protocols and sensibilities that people have. It's not in integrated assessment models. They don't have this kind of stuff. It's not regulated by governments that regulate these things. It's a new pathway. And so people are sort of trying to figure out what to make of this thing, but fundamentally it works. I can't speak about graphite as a company to invest in or what they work or anything like that, but fundamentally, taking biomass out of the system is part of the conveyor belt from the air to the subsurface. And if you can do it in a way that is durable and you can do it in a way that's easy to monitor and measure, you got something to do.
Thank you guys so much. Great to see you. And we will be back next week. Darren and Julio, thanks for joining us.
Talk to you guys soon.
Until then.
That's it for this week on Climate News Weekly. See you next week.